Hello and welcome to the post-lab reflection for the Module 3 labs. In this video, I'll be going briefly over the experiment design and some of the safety precautions and the results. I'll also be considering potential sources of error within these labs and then reflecting on my experience with the labs and how the concepts that we learned this week applied to these. In this first experiment, we will be testing the hypothesis that we can determine the formula of copper gluconate by isolating the copper from the gluconate in the compound and then calculating the molar ratio of the two. First, I will be going over the experimental design and safety precautions for the first experiment. So, for the first experiment, we'll be creating a solution mixture that has copper gluconate and sodium chloride. This mixture will be heated in order to separate out the copper granules from the rest of the solution, and then those will be heated in the oven to dry out so that we can take an accurate measurement. The result of this experiment will be to be able to use some critical thinking skills to see the measurement of copper in the copper gluconate and use that to decide what the formula would be for copper gluconate using analysis. Some of the safety concerns for this experiment involve fire, broken glass, and chemical spills. For the fire portion, everything will be set up beforehand so that the flame can be going for as short of a time as possible. It will not be left unattended. And there is the fire extinguisher close at hand and ready for use. It's slightly out of the way so as not to be a tripping hazard, but close by so that it can be used very quickly. Additionally, for the chemical spill portion, I have a cloth here to clean it up, and that would be disposed of in the trash can. We have to be careful not to let anything go into the wastewater system. Additionally, I do have long sleeve cotton clothes on, and I have nitrile gloves. However, the gloves will come off while the flame is being worked with so as to not have a burn risk. I also have on some splash goggles to protect my eyes. And as far as the risk of broken glass is concerned, there is a broom in the room close by to sweep up glass, and glass will be handled with extreme caution. In the second experiment, I'll be attempting to melt a variety of solid chemicals in order to make some sort of educated determination about how the melting point of a chemical is influenced by the bond type and the strength of those bond types. For the second experiment, we'll be looking at the melting point of a few solid substances: sucrose, stearic acid, and sodium chloride. We're doing this so that we can make an educated prediction about the type of bonds within these substances. And just like the last experiment, we will have some similar precautions that we need to take. We will be working with some substances that require gloves and protective gear. However, once the flame becomes part of the experiment, the gloves will have to come off as a safety precaution. Also, we have similar flame precautions such as a heat towel that I can use and a heated glove. We also have the fire extinguisher handy. So all of those precautions are in place, and then of course we have our spill measures as well with the paper towels and also with a regular towel. In the results for the first experiment, I found that there were about 0.13 grams of copper in the compound, which translates to about 0.00205 moles of copper. Subtracting the weight of copper from gluconate, we got about 0.87 grams of gluconate, which translates to approximately 0.00446 moles of gluconate. Now we can compare these molar results to see that there's about a 1:2 ratio of copper to gluconate in the compound, which means that when we look at the formula, we see that gluconate is twice as much as the copper, so our result for the whole thing would be about C12H22O14 copper 1. So the results of the second experiment were pretty interesting. I was not able to get the sodium chloride to melt within 5 minutes. I predict that the bond type is ionic because it has a high melting point, but we also know that sodium chloride dissolves pretty well in water. For the stearic acid, I was able to get it to melt within 79 seconds, which was pretty fast, so I would predict that maybe it has a nonpolar covalent bond. And finally, with the sucrose, I was also not able to get the sucrose to melt within the 5-minute time limit, but I don't believe that it has an ionic bond like the sodium chloride, so I'm going to predict that it has a polar covalent bond due to the high melting point. Two potential sources of error that I identified in both experiments are systemic in nature. The first being perhaps an instrument type of error, systemic instrument error, due to the readings of the scale. I noticed that the scale wasn't always very consistent and sometimes it needed to be reset. So it could be some sort of measurement or calibration error on that end. Another source of systemic error would be in the second experiment with the positioning of the solid chemicals over the flames when we were looking at melting points. It's possible that maybe I wasn't able to achieve any melting for two of the substances due to a misreading of the distance between the flame and the containers that the substances were in. Could also be that there were some issues with how the aluminum was holding up against the flame in that experiment. A second source of error for both could be another type of systemic error, but this time an observation error or a human error on my end. Perhaps I conducted a miscalculation whenever I was weighing out the copper, or perhaps I inaccurately set up the experiment for the second test when we were looking at melting points. The first concept that these labs really helped me experience this week is the idea of stoichiometry, and that we can kind of compare the ratios of the materials in a compound and take whole number ratios in order to deduce the formula for the compounds that we're looking at in an experiment. And this was really interesting to see in action. Even if the calculations were slightly off or there were some errors, we still managed to find a ratio that made sense. The second concept I looked at here is the idea that we can make an informed guess about the type of bond based on certain physical properties that we can observe, like the melting point. We know that certain bond types have higher or lower melting points than others, and this can tell us a lot about the strength of the bonds that are in a substance and why those bonds may behave in a certain way under certain environmental stresses. In this case, looking at the melting points, we could determine what type of bonds due to the way that those bonds respond in high or low temperatures. And finally, we have this idea of errors that we can encounter in experiments. And this is always interesting to me because you can't always say with 100% certainty that you have zero errors, and you always have to expect that there will at least be some, but it's always somewhat difficult to determine exactly what type of error you're facing in a particular experiment. I think that this is something that mainly comes with experience and time and practice, so it was really fascinating to look at it in this experiment. And that concludes the post-lab reflection for my labs for Module 3. Please let me know if you have any questions or concerns, and thank you so much for your time.